Hello everyone and welcome to lesson 6.1.3. How can I describe it? In the last two lessons we have been talking about slides, turns, flips, and what's happening to shapes when we do those three rigid transformations. Today we're going to work on describing what's happening to those shapes and paying attention to the coordinate grid as that happens. So here we go. Describe how Rosa transformed ABCD into WXYZ. This shape turned into this shape. You can see my arrow there. Question, does it look like Rosa did a slide, flip, or a turn? Well, I'm hoping you said slide. How do we know that Rosa did a slide? Okay. Oh, I know Rosa slid, past tense. She slid this quadrilateral because I want you to notice it's pointing in the same direction. In the same direction. I know Rosa slid ABCD because it is pointing the same direction. That is the key with a slide. When you do a slide, here, let me perform a slide right here. Listen out on me. Erase, mouse, slide, slide. Notice that it's the exact same shape, exact same size, exact same position. Okay? So you can write, you know it slid because it is pointing in the same direction. The question is, in B, how much did it move? Okay? If I take this shape back to ABCD and I count 1, 2, 3, 4, 5, 6, it went right 6 and up 1, 2, 3, 4, 5, 6, 7, 8. Notice all I'm doing is I am counting how much this shape moved. I have it as a whole and I just slid it. Let's pay attention to B's coordinates. I noticed that B on the graph is -3, -5, and X's coordinates are 3, 3. How much did the X coordinate change? Right here. How much did it change? Well, 3 minus -3, 6. What a coincidence. How much did the Y coordinate change? Well, 3 minus -5, 8. What a coincidence. So I want you to write, letter D, the X coordinate changed by 6, and the Y coordinate changed by 8. Okay? Now, I notice what's happening here is when you do the math, all we are doing is -3 plus 6 gave us the new coordinate 3. -5 plus going up 8 gave us the new coordinate 3. Notice that all we did was we added the slide to the coordinate grid. So if on this coordinate grid X is slid to the right 10 and then goes up 12, where would that coordinate land? Well, if it started at 3, 3 and you add 10 to the X coordinate and add 12 to the Y coordinate, write down your new coordinates. All we need to do is pay attention to what's happening in the math, and then we can predict really large numbers. Rosa translated a different shape on a grid. Use the clues below to figure out how her shape was moved. She had a point, this is A, at 4, 7. Now I want you to notice this is very similar to like 2nd, 3rd, 4th grade math when we're adding really large numbers and you have to pay attention to place value. 1's place, 10's place. hundreds place, and so on. It's very similar to that, except we're paying attention to the X column and the Y column. That's what we're doing here. Now, when Rosa was working, the point 4, 7 was translated. It's a mystery, and it ended up at 32, -2. So here's the question. What do you do to 4 to get to 32? What do you do to 7 to get to -2? Go ahead and write your answer down like this. Slide X plus number. And because that Y value went down, you write your minus number. Okay? Write that in. Problem letter B. Another point on her original shape was -16, 9. After this translation, where does this point end up? So you're going to take this slide. You're going to apply it to -16, 9, and you're going to tell me what is the new coordinate. Okay? This is an important skill because just like when we were doing equations, we started with tiles, but tiles got so big, we started doing the math. Then we were graphing and graphing and graphing, and then all of a sudden the numbers became too big, and we did the equal values method. The same thing is happening here. We can have a shape on a coordinate grid, but eventually the coordinates are going to get so big that you need to be able to do the math. So 6-20, Rowan. Rowan transformed this quadrilateral CDEF to get PQRS. Okay, so we did this. Question, what did he do? Did he slide like the previous problem? Well, now I noticed that the orientation here is opposite. I noticed that this one kind of looks like it's pointing in this direction, and this one is pointing in this direction. Which transformation has those mirror images? You need to write, I know Rowan flipped. CDEF, because the images are opposites. The images are opposites. Now I want you to write down these coordinates for letter B. C is -6, 6. D is -1, 6. E is -3, 1, and -6, 1. Okay, here's what I want you to do. I want you to look at P, 7, 6, Q, 1, 6, R, 3, 1, and S, 6, 1. What happened? What happened there? Pause the video. Think, what happened there? Okay, after you pondered this for a second, you should notice that my negatives became positive, but only the x's. So I want you to write, I notice the x values flipped. The y values stayed the same. The x values flipped. I'm going to go ahead and put that inside my quadrilaterals, because I want you to notice that when you flip a value to the opposite side, it becomes the opposite sign. That's like solving equations, Mr. McCoy. But instead of flipping over the y-axis, it's like flipping over the equal sign. So when we're flipping over an axis, the opposite occurs. So you need to notice, I notice the x values are opposites, or the x value got flipped, the y value stayed the same. To do a flip, you do not use addition or subtraction, you use multiplication. Multiplication. Because a negative times a negative equals a positive. Okay. Now, 6-21 is on this exact same graph. Okay? Rowan is then learning that, wait a second, I can just take these coordinates and I can multiply it by -1, and I'm going to get the flipped shape. And that's correct. And so here's what we have. If I start with a fresh page, you have this still same graph. Okay? But instead of flipping it over the x-axis, or the y-axis, I'm going to flip it over the x-axis. So when I do that, I'm looking at a positive y. It's up top. And when you flip it down below, the shape is going to be a negative y. Pause the video and see if you can. Don't mind that interruption. So here's what I want you to do. Pause the video, try and do that flip. Okay, welcome back. You should have done a flip. Now, for those of you who are just waiting for answers, you got to be able to do a flip. If it's 1 away from the flip, then it's 1 away from the flip. Notice, 1 unit, so 1 unit. You went straight down. 1 unit, 1 unit. I did the top, you do the bottom. All right, problem 6-22. Now you have a piece of graph paper. What I want you to do is I want you to graph those 3 coordinates. Graph those 3 coordinates and pause the video. Okay, you have your 3 points plotted, and what I want you to do is I want you to multiply the x value only by -1. I know that looks like x minus 1, but it's supposed to be times -1. So here we go. Negative times negative, positive 3. Positive times negative, -1. 0 times negative, still 0. Plot those points. And what I want you to ask yourself is, did it get reflected over the y-axis? It looks a little bit different though, doesn't it? Because see, you are used to thinking, oh, what's on this side of the mirror goes to the other side of the mirror. But what happens when the mirror is in the middle? Well, both sides got reflected to the opposite side. There's a children's toy that uses this mathematical principle. It's called a kaleidoscope. And you look through the kaleidoscope, and as you twist it, the mirrors adjust the geometry in what you see, and you see different geometric shapes. So this is our final summary of our 3 rigid transformations. You have a lot of space to do some writing. Okay, if you would like to pause the video to write these blanks, feel free to pause now because I won't slow down. Pause the video now. Okay, so the 3 rigid transformations. If we are going to talk about a slide, what is happening to a shape when we slide? Well, here, if you slide side to side, or forward or backward, do you change shape? No, you do not change shape. Same shape. Same size. What about direction? If I go side to side, notice I'm still facing the camera. That means that it is the same direction. In a slide, same shape, same size, same direction. Reflection. When I do a reflection in the mirror, when you stand in front of a mirror, does your shape look the same? Yes. Does your size look the same? Yes. But the direction is not the same. The direction is opposite. So what we're going to do is we're going to say same shape, same size, and opposite direction. Because they're facing each other, top or bottom, right? When you do a rotation, you are going to get the same shape, the same size, but you are going to get a different direction. Because, see, if I do a rotate off my left foot and I rotate once, notice I'm just facing a different direction. I'm not facing the opposite. I'm just facing a different direction. Okay. Thank you for coming to lesson 6.1.3. How do we describe our rigid transformations? Stay tuned for lesson 6.1.4. Thanks for coming today.